Something is racing through our solar system and hiding in the one place. Our best telescopes hate the glare behind the Sunday Harvard calculations point to a narrow window, November 21 to December 5, when rumors face reality. Cosmic coincidence or deliberate arrival? Stay, and let's test this together. You and I are stepping into a rare kind of story, one with a countdown and a scoreboard. An interstellar object, 3I divided by Atlas, has slipped in from deep space, cut across the inner solar system, and ducked behind the sun at the exact moment the internet learned just enough to panic. In threads and forums, every fuzzy image becomes a smoking gun. Every delay becomes a plot. But here's our ground rule from the start. Nothing gets a free pass. Not the wildest hypothesis, and not the safest conventional wisdom. We measure, we check, we let data embarrass us if it must. So what is the paradox we're trying to untangle? On one side, a tidy explanation, an unusually icy, unusually massive comet behaving strangely because nature, frankly, is weird. On the other side, a list of eyebrow raisers that refuse to sit quietly, alignment probabilities that seem too convenient, brightness changes that jump instead of glide, and a dust shape that looks like it's leading rather than trailing. Could instruments push past their design limits and lie to us? Absolutely. Could our brains, primed by years of sci-fi and a few real anomalies, see patterns in noise every day? But could a carefully engineered object masquerade as a natural visitor and pick the one stretch of sky where we're most blind? If you were trying to move unobserved, you might choose the sun's spotlight too. Here's how we'll keep this honest. We're going to set tests before we know the answers. Post-perihelion, a natural comet should fade along a predictable curve. It should keep its course within the nudge of physics. Solar radiation pressure, outgassing jets, nothing dramatic. Its rotation should wobble like a lumpy snowball, not tick like a metronome. Its chemistry should look extreme but plausible for an object forged far from our sun-exotic ratios, sure, but still born in ice and dust, not alloys and wiring. If those predictions hold, we tip our hats and file 3I divided by Atlas under magnificently natural. If even one of them breaks hard, if brightness stalls or surges when it shouldn't, if the path trims itself against expectations, if the rotation locks in with suspicious neatness, then the conversation changes, not to certainty, but to upgraded curiosity. And yes, the calendar matters. The reason that November 21 to December 5 window has everyone buzzing is simple. It is falsifiable suspense. We're not waiting decades for a probe. We're waiting days for sky positions that bring 3I divided by Atlas out of the glare and into the reach of an armada ground, telescopes, space instruments, and the kind of citizen astronomers who routinely shame billion-dollar optics with meticulous patience. If sweeping claims are true, they won't need poetry to announce themselves. The plot will move in photometry, spectra, and orbits. Let's acknowledge the human part of this. We're pattern seekers, living in an age where extraordinary discoveries happen so often they blur together. We've seen interstellar visitors before the needle of Oumuamua and the snowball of Borisov, each forcing us to redraw what normal looks like. That alone should cool the hottest takes and fuel the most cautious wonder. But we've also watched real mysteries linger at the edges of certainty, stubborn as a riddle you can't quite phrase. That should keep us awake. So, here's the deal between us. I'll keep the pace up. You keep your skepticism sharp. We'll balance narrative urgency with analytic breaks, and we'll pin every dramatic line to a measurable hook. When the sun lets go and the data arrive, we won't move the goalposts. If it's a beautiful comet, we'll celebrate a beautiful comet. If it's not, then we get to write the first chapter of a different kind of story. Let's anchor the basics before the rumor engine revs again. 3I divided by Atlas is the third interstellar object humanity has ever tracked, streaking through our neighborhood. First came Oumuamua in 2017, a needle without a tail, then Borisov in 2019, a textbook comet from another star. Now this one, a visitor with timing and geometry, mischievous enough to feel scripted. It enters the inner solar system, begins to wake up under sunlight, and then right as interest spikes slips into the worst possible place for observers, directly behind the sun from Earth's point of view. You couldn't pick a more dramatic intermission if you tried. So why did that single fact, it's in the glare, ignite the internet? Because a blind spot isn't just an absence of data, it's a vacuum where stories breed. When we can't watch closely, every delayed image becomes suspicious. Every bland press note feels like a dodge. Could this all be a cosmic coincidence? Or is something else going on? That question is catnip to humans. Add a countdown late November into early December when the object should re-emerge, and you've built a natural cliffhanger with a payoff date. Before we sprint to conclusions, let's map what we can and cannot reasonably expect from instruments. Spacecraft near Mars grabbed frames not designed for distant, faint targets. That's why you saw fuzzy dots instead of magazine cover portraits. Surface imagers and atmospheric spectrometers were never meant to turn into long-range comet cameras. But even a fuzzy dot can speak. Brightness over time, motion against background stars, changes in the size and shape of the surrounding coma. From Earth, big observatories will take over once the sun's dazzle loosens, using more suitable sensors and techniques, long exposures, careful stacking, even interferometry that stitches multiple telescopes into one sharper eye. Here's the critical mindset shift. Good science starts with constraints. What's measurable soon? Photometry, the object's brightness curve, will tell us how fast it's waking up or settling down after swinging near the sunday. Spectroscopy light split into fingerprints will test claims about chemistry, that eyebrow-raising carbon dioxide to water ratio, the whispers of complex organics. Astrometry pinpoint positions night after night will refine its path to a precision that can reveal subtle forces nudging it. Rotation can be inferred from periodic flickers as irregular surfaces spin through sunlight. None of this requires a secret camera or a conspiracy hotline. It requires time, clear skies, and boring, beautiful repetition. Why did the conversation get so loud so fast? Because 3i divided by Atlas arrives with inheritance. Oumuamua trained us to respect the unexpected, acceleration without obvious outgassing. Borisov reminded us that Interstellar can still look classic, a coma, a tale, familiar chemistry. 3i divided by Atlas seems to sit between those archetypes, borrowing strangeness from one and normalcy from the other. That ambiguity is gasoline. It lets two camps talk past each other. It's obviously a comet versus, why is the dust behaving like that? Both have pieces of the elephant, neither has the whole animal yet. Let's also be honest about the social physics. Platforms reward heat, not humility. A clean curve that fits a model travels slower than a screenshot, with a red circle and 9 exclamation points. The way out isn't to scold curiosity, it's to give curiosity a sharper toolkit. Ask questions that cash out in data. If you believe the object is maneuvering, what change in its post-sun trajectory would prove that? If you think the chemistry screams unnatural, what spectral lines would need to appear or vanish? So yes, 3i divided by Atlas took over the internet because it sits at the intersection of mystery, timing, and a very human desire for a plot. But here's the good news. This is not one of those enigmas that drift for decades. The sun will move, the glare will fade, and when it does, telescopes on Earth and in space will flood the void with numbers that don't care about hashtags. Our job is simple and hard at once. Hold the question steady until the answers arrive. Let's rewind to the moment this object earned its first passport stamp. A survey telescope flagged a moving point that didn't fit the usual family of long-period comets or main-belt strays. Plug the early positions into orbital software, and the solution snapped into focus. Hyperbolic, not bound to the sunday. That one word hyperbolic means it's coming from interstellar space, not looping back from our own Oort cloud. The speed at infinity, the excess velocity after gravity's tug, sealed it. We weren't watching a homegrown wanderer, we were watching a traveller. From there, the line on the sky began to tell a story. Each night's astrometry nudged the parameters tighter. Inclination, argument of perihelion, longitude of the ascending node. The more dots you plot, the straighter the narrative gets. But then came the part that made headlines claims about improbably tidy alignments with the orbital planes of Venus, Mars, and Jupiter. Numbers like 0.2% were thrown around, implying a lottery win on cosmic scales. Picture the metaphor you saw repeated. Someone throws a dart blindfolded from another city, hits the spinning bullseye, and does it while the board itself is gliding down a hallway. That image is sticky because it feels like a miracle. It also cheats a little, and we should say why. Space is big, yes, but gravitational dynamics are not evenly random everywhere. Our solar system is a set of lanes carved by billions of years of mass and motion. If you feed more realistic priors into the problem, galactic tides slowly stirring paths, long encounters with diffuse clouds, the fact that detection probability favors tracks close to our ecliptic where we actually look, your odds change. Suddenly, what sounded vanishing becomes merely small. Fold in improved modeling and the 1 in 500 headline shifts toward 1 in 50-ish. Rare is not the same as rigged. So, could an object just happen to skim by those planetary planes and still be natural? Absolutely. We are selection-biased observers with instruments built and scheduled to favor particular sky swaths. We are more likely to notice the travelers that pass through our traffic circle than the ones that zip by far above our heads. The intelligent move is to treat improbable alignments as a nudge to look harder, not a verdict. Then the sun pulled its favorite magic trick. It took the story away. As 3i divided by Atlas slid toward superior conjunction, the geometry shoved it into daylight glare. Telescopes that had been chalking neat little points suddenly had to stand down. Suspense doesn't need a soundtrack when the universe writes its own intermission. If you were building a narrative, this would be the act break. If you were planning to act unseen, this would be the window. That's the duality that keeps tempers high. Mundane physics produces a perfect stage cue, and conspiratorial minds hear their theme music swell. What can we salvage from the pre-sun arc while we wait? Direction, speed, and curvature already give us a canvas large enough to see broad forces at work and to see what isn't there. No obvious planetary flyby dumped energy into the trajectory. No sudden cross-track jiggle screamed thrust. The inbound vector points to a region of the sky that, while not uniquely identifying a birth cluster, fits the story of an object stirred loose by time, tides, and chance. If you squint, you can sketch a route through the galaxy's thick disk, where colder chemistry might have set that odd carbon dioxide richness. If you don't squint, you simply say, it came from out there, not from here. So where does that leave our dartboard? Less miracle, more math. Less destiny, more dynamics. Still, lines on the sky carry hints of intention because humans carry hints of drama. The clean way forward is not to outlaw the metaphor but to cage it with measurements. When 3i divided by Atlas clears the sun and the dots resume, we'll know whether that early trajectory was a prologue to normalcy or a curtain hiding a second act twist. Until then, the line holds, and so do we. Let's talk about the 3 words that keep sneaking back into every discussion: mass, acceleration, and shape. If 3i divided by Atlas is just a comet, its mass should sit in a range we've met before: icy rubble, loosely held, outgassing as sunlight bites in. But the inferences people passed around in the early weeks pointed higher than comfort, as if this nucleus were less potato and more planetesimal. Could those numbers be inflated by coma brightness masquerading as bulk? Yes. Estimating mass from light is a trap with a well-greased floor. You need albedo, particle size distributions, phase angles, and a sober respect for error bars. Still, when multiple independent approaches whisper, heavier than average, it's worth a pause. Acceleration is the second siren. Natural comets accelerate in ways we can predict because jets of vapor act like tiny thrusters. It's messy, but not mysterious. You see a warming face, you see a push. With Oumuamua, we hit a snag. Measurable non-gravitational acceleration without an obvious gas signature. That's how 1,000 think pieces were born. With 3i divided by Atlas, the claim isn't that acceleration exists, that part is normal, but that its pattern looks jumpy, as if switches were being flipped rather than a stove slowly heating. Could uneven patches of supervolatile ices do that? Absolutely. A buried seam of carbon monoxide or carbon dioxide can sleep for months, then go live the minute sunlight tunnels in through a crack. What matters is correlation. If jumps align cleanly with thermal models and rotation phases, the natural story wins. If they don't, we circle back. Then there's the picture that won't leave our heads, a teardrop that leads, dust tails trail, that's Comets 101. Solar radiation pressure pushes fine particles away from the sun, sculpting that romantic arrow we've been drawing in children's books for 2 centuries. So why did some images, especially low signal stacks, feel like the bright stuff was in front? Here's where intuition and optics collide. Point spread functions, background subtraction, slight misregistrations across frames, these can all forge a false nose. The coma is a spherical glow that looks different when you carve it with imperfect tools. If you want to test the weird leading cloud idea, you don't do it with a single dramatic frame. You do it with sequences, with controlled processing, with different instruments agreeing across nights. Let's pull back and compare our rogues gallery. Borisov was a comfort blanket. Classic coma, classic chemistry, classic tale. Oumuamua was a riddle cube, elongated shape, no obvious dust, yet a nudge away from pure gravity. 3. I, divided by Atlas, seems to wear a reversible jacket. From the Borisov side, you see an active body outgassing, surrounded by asymmetry as sunlight wakes it up. From the Oumuamua side, you see hints of tidy periodicity, brightness jumps that feel binary, and a geometry that taunts. Could nature do both at once? She has a history of showing off. The fair question, the one that cuts through forum fog, is not, does the picture look weird? But what mechanism would make that picture inevitable? For a natural comet, you'd propose jet anisotropy, vents clustered on certain longitudes, turning on as the spin brings them into dawn. You'd propose cohesive crusts cracking, releasing trapped CO2 that snowplows dust forward in the nucleus frame, even as solar pressure still drives the finest grains backward in the sun's frame. For an engineered object, you'd need a reason to drag a bright cloud ahead, active scooping, bow-shock interaction with a deliberately emitted field, and then you'd need predictions that survive contact with new data. The bar is higher than it looked odd at low SNR. Speed? Interstellar visitors carry a birthright of fast. Excess velocity is the one trait they don't have to explain. But speed plus mass plus activity tells you something deeper. How easily sunlight can torque the spin, how much a jet can deflect the path, how quickly surfaces evolve near perihelion. Those are the levers we're about to watch. If 3I divided by Atlas is lumpy, jets will tumble it. If it's smooth and stubborn, the rotation may hold a clean beat. If its dust cloud really does lead, different instruments will converge on that result without Photoshop heroics. Our job isn't to crown a champion between romance and rigor. It's to keep asking the next testable question. When the glare lifts, mass proxies will sharpen. Acceleration curves will either jitter in step with heat or wander off script, and the so-called teardrop will either dissolve into processing artifacts or harden into a physics lesson we didn't know we needed. Either way, intuition is about to meet evidence in open court. Start with the most humbling image in planetary science, a glowing speck that refuses to be more than a few saturated pixels. That's what Mars orbiter cameras gave us when they swung their attention from dunes and dust devils to an interstellar target tens of millions of kilometers away. These instruments were built to read sand-grain shadows from low orbit, not to paint portraits of a dim traveler across interplanetary space. So the frames look underwhelming. At first glance, soft dots, uneven halos, hints of asymmetry that could be physics or could be optics having a long day. And yet, there's value in the humility. Even a fuzzy dot, tracked with discipline, becomes a time series. Brightness up, brightness down, coma expanding, coma skewing, all against a background of stars that do not lie. Here's how a bad camera can still do good science. When you stack many exposures and register them on the moving target, you build a heartbeat of the coma, the gas and dust envelope that a waking nucleus breathes into space. Its radius tells you how vigorously the surface is venting. Its shape whispers where the vents are. If the comet's morning face keeps coughing in the same rotational phase, the halo will develop a preferred direction. That can look like a lopsided smear or a fan that leans. You don't need cinema for that, you need cadence. Night after night, the pattern either repeats in step with a spin solution, or it doesn't. Then comes the part that made compositional chemists lean forward, an unusually high carbon dioxide to water ice ratio, far beyond what our homegrown comets typically flaunt. Water is the usual king of cometary ices. Carbon dioxide is the dramatic uncle who visits less often. If CO2 dominates, that points to formation in colder, darker nurseries, where water either never condensed efficiently or was buried under layers that keep it shy. Add to that the spectral hints of complex organics, larger, more delicate carbon chains that we don't expect to survive, carefree for millions of years in harsh radiation, and the story grows teeth. You can tell two honest tales from the same clues. 1. This is a natural body born in a chemically exotic system, a time capsule carrying alien ice recipes. 2. Someone built a thing that wears an icy cloak tuned for endurance and deniability, and we are reading the cloak, not the core. So how do we decide without fooling ourselves? Extraordinary claims demand extraordinary evidence is a slogan. Let's translate it into tests. If the chemistry is natural, spectra taken at different phase angles and heliocentric distances should evolve, in ways our sublimation models predict. As sunlight climbs, CO2 and other volatiles should breathe in ratios that follow temperature and depth, not marketing. The organics should photolyze and attenuate at rates that match lab cross-sections under UV assault. If the chemistry is staged, you'd expect less graceful change, plateaus and step functions, as if reservoirs were being accessed by schedule rather than heat. You'd expect certain lines to stay suspiciously constant across conditions that should have jostled them. Dynamics offers another kind of verdict. Venting creates torque and thrust in known directions. If Mars images and later Earth images show the coma's long axis precessing in lockstep with a rotation solution, and if the non-gravitational acceleration vector tracks the sun-facing vents like a weather vane, that's nature doing her messy, predictable thing. If the vector refuses to follow the sun, or if the periodicity remains eerily stable across heating regimes that should wobble it, the eyebrows rise. There's a reason the SETI crowd both smiled and frowned when the CO2 stories broke. On one hand, exotics are exactly what you expect from interstellar stuff. On the other, a surplus of exotics makes it easier for a clever designer to hide. The right move is to keep the designer in the room, but off the mic until the numbers invite them to speak. That means more spectra from better-suited instruments, more nights of coma geometry tracked with discipline, and a data culture that shares raw frames so independent teams can fail in different ways. An underachieving camera around Mars started this chapter. Sharper eyes will finish it. If the chemistry and the coma dance to the sun's rhythm, the natural score wins. If they dance to a beat we can't tie to heat, rotation, or dust, then the music is coming from somewhere else. Circle the dates on your mental calendar. Late November into early December. That's when the glare relaxes, the object slides back into darkness, and the world's largest eyes swing into position. Picture the Very Large Telescope in Chile stitching light from multiple mirrors into one sharper gaze, while arrays elsewhere coordinate to build time series brightness curves so clean they can pick out a heartbeat in a hurricane. This is when suspense turns into spreadsheets, and that's good news for truth. Here's the simple plan that isn't simple to execute. First, photometry. Night after night, we measure brightness as a function of time and distance from the Sunday natural comets follow power laws. They brighten predictably inbound and fade predictably outbound, with wiggles that correspond to rotation and patchy activity. If the curve plays by those rules after perihelion, reassurance grows. If it flattens when it should fall, or surges in stepwise jumps, unrelated to thermal input, curiosity grows teeth. Second, spectroscopy. We spread the light into fingerprints and watch the lines breathe. Carbon dioxide, water, carbon monoxide, organics, they should wax and wane as sunlight drills into different layers. Phase angle matters, heliocentric distance matters. If lines refuse to shift across changing conditions, or if brand new features appear and vanish on human schedules rather than solar ones, we take note. Third, astrometry. It sounds unglamorous, plotting positions against background stars with absurd precision, but this is where the quiet revolutions hide. Stack enough nights, and you can see forces smaller than a whisper. Solar radiation pressure is gentle. Outgassing thrust is pushy but tied to the Sunday Yarkovsky-like effects nudge over seasons. If the reconstructed path holds steady within those expectations, good. If the trajectory trims itself cross-sunward without a plausible jet solution, that's different. We're not hunting for movie-style turns, we're watching for millimeter-per-second betrayals that add up. Now the spicy part, rotation, early. Analyses hinted at a complex tumble with an oddly crisp repetition, something like 17.3 hours to return a familiar face to the Sunday. Tumbling bodies can do that, but tidy periodicity across heating regimes is a tell. Comet surfaces are fickle, vents clog, crusts crack, torques drift. Over weeks, periods wander. If we watch 3i divided by Atlas and the light curve keeps drumming the same beat through perihelion and out the other side, we'll ask why. Natural explanations exist. Deep-seated moment of inertia, activity confined to latitudes that stabilize spin, a nucleus stout enough to shrug off torque. But the more the beat refuses to budge as circumstances change, the more interesting the story becomes. We also owe the alignment math a second look now that the arc will lengthen. Early claims of vanishingly small odds for the orbital geometry softened when models included galactic tides and observation bias. Going from roughly 0.2% to around 1.8% doesn't make it common, it makes it survivable. Fresh data will either anchor those improved priors or pull them back towards spectacle. This is where large telescopes earn their drama quietly by reducing error bars until hype has no oxygen. A word about technique. Expect interferometry trials, where separated telescopes act as one to push resolution beyond any single mirror. Don't expect glossy magazine shots of the nucleus. Expect constraints, upper limits on size, hints about shape, maps of coma, anisotropy moving in phase with spin. Expect amateurs to matter too. 1,000 modest apertures, coordinated and calibrated, can cover weather gaps and catch flickers with the big guns miss. Could this all be a cosmic coincidence, or is something else going on? That refrain stays on the wall, but it's losing power as instruments come online. If brightness decays along a sane curve, if spectral lines behave like heated ice and dust, if the non-gravitational push points to the sun and the rotation period wanders like a real rock, our verdict will be straightforward. If not, we won't need to shout. The plots will do it for us. By mid-December, the telescope army will have spoken in numbers, patient, unfashionable, decisive. So what if it's not a camera trick? What if the neat periodicity, the jumpy acceleration, and the awkward dust geometry are all symptoms of design rather than geology? Entertaining that possibility doesn't mean we've abandoned skepticism. It means we're brave enough to draft testable ideas before the next batch of data arrives. Start with the costume. If you wanted to cross interstellar space quietly, you'd pick a thermally robust shell that looks like ice and dust from every sensible angle. Ice is self-healing under sunlight, radiatively stealthy, and compositionally deniable. Relax. It's a comet. A thin regolith or engineered crust could sit over volatile reservoirs that open and close on schedule, not just temperature. To us, that would look like stepwise brightening instead of smooth curves. Prediction 1. Activity events occur at spin phases that don't track local dawn, and they repeat with clock-like regularity through heating changes that should smear them. Now the engine, if there is one. Nothing in the data demands thrust larger than what outgassing can supply. But if tiny, directed impulses were layered on top of natural jet's microcourse trims, rather than cinematic turns, we'd see millimeter-per-second leaks in the astrometry that don't point to the Sunday. A disguised propulsion mode could be electrostatic or electromagnetic, interacting with the solar wind like a sail we mistake for dust dynamics. Prediction 2. Reconstruct the non-gravitational acceleration vector over weeks. If it tracks neither solar radiation pressure nor modeled vent geometry, something is pushing that isn't heat. How about the tease of a leading teardrop in a natural frame? That's hard. In a designed frame, a bow shock or a forward-scooping field could herd nanograins into a luminous nose. It wouldn't need to be strong, just coherent over a few nucleus radii. That coherence would show up as the same forward asymmetry across instruments and processing pipelines, not a quirk that vanishes with different point spread functions. Prediction 3. Independent teams, using different reduction methods, recover a persistent foreglow whose position angle stays locked in nucleus coordinates even as the sun angle changes. Then, motive and mission. Why send anything here at all? A courier makes sense over galactic timescales, a durable bus carrying message, seed, or sensor. The priority would be survivability, not speed. It would minimize active energy use, exploit long coasts, and wear a chemical cloak that keeps micrometeoroids and radiation at bay. If it wanted a quick peek at us, the sunblind window is irresistible. A few weeks to deploy something small toward favorable geometry without Earth-based eyes. No fireworks needed. Prediction 4. In late November, small transient sources briefly appear along the anticipated line, connecting 3i divided by Atlas and Earth's orbital motion too faint for headlines, but real in stacked, wide-field surveys. Rotation is the psychological tell. Natural bodies wobble and drift as vents open and close. A vehicle with spin-stabilized sections or reaction mass management might keep a surprisingly crisp beat across heating regimes. That doesn't prove intention. Stubborn inertia can do that too, but if the period survives perihelion with minimal wander, we interrogate harder. Prediction 5. Rotation period stays within a tight band, while local activity indicators change, implying decoupling between torque and spin. Finally, information. The cleanest signature of design would be a modulation, something encoded in brightness, polarization, or radio reflections that repeats beyond what surface features can reasonably explain. We're not talking Hollywood beacons, we're talking low-rate, redundant patterns that survive chaotic environments. Prediction 6. High-cadence photometry or polarimetry reveals a secondary periodicity nested within the main rotation, stable in frequency but drifting in phase as if written by an internal clock. Could all of this collapse back into interesting comet when better data arrive? Absolutely. That's the point of making the ledger explicit now. If the non-gravitational vector hugs the sun, if the brightening follows temperature and not timetable, if the foreglow melts away under cleaner reductions, then we cheer for nature's inventiveness and move on wiser. But if even one of these predictions lands with numbers, not vibes, then we've crossed from fun speculation into a new category of question. Either way, we win. We gain a stronger template for separating engineered-looking noise from engineered reality. We give ourselves a way to say no without hand-waving, and a way to say maybe without apologizing. The next few nights will reward that discipline. The costume is convincing, the stage is perfect. Now we wait to see if the actor ever breaks character. Here's the thing no one tells you about mysteries like 3i divided by Atlas. The best way to understand one strange object is to widen the frame until it stops looking strange. That's why tonight isn't a single thread obsession. It's a braid. We're going to keep the tension of the visitor while moving through other frontiers: exoplanets, quantum computing, fusion power, age reversal, brain-machine links, and the psychology of memory, because taken together, they recalibrate your intuition. When everything else in science is accelerating, unlikely starts to feel different. There's also a storytelling reason to do this, and it's practical, not poetic. Attention isn't a tank you drain, it's a muscle you train. The fastest way to lose you is to grind on one unresolved claim for an hour. The fastest way to keep you is to alternate sprints and strolls, hard data here, speculative question there, a breath of wonder, then back to the scoreboard. Think of it like interval training for curiosity. Short, energetic bursts that feed a longer endurance. Each brief changes the angle of light on Atlas without derailing it. So what's the unifying thread? It's not aliens, it's measurement. Across every field we're about to visit, the story is the same. Better instruments, cleaner methods, and weirder results than anyone predicted 10 years ago. Exoplanet hunters read alien skies from the faintest dips in starlight and find iron rain and lava oceans. Quantum engineers beat error long enough to simulate molecules that used to laugh at supercomputers. Fusion scientists hold star-hot plasma for minutes that matter and talk grid timelines without flinching. Biologists don't just slow aging in animals, they roll parts of it back and watch function return. Neuroscientists pull words out of electrical whispers and let bodies speak again after years of silence. Psychologists show how memories can be rewritten and how to defend them. What does any of that have to do with a teardrop of dust or a bus in disguise sliding out from the sun? Everything. The same discipline that turns stellar flickers into weather maps also turns comet flickers into spin solutions. The same statistical humility that separates quantum hype from quantum winds keeps us from jumping at shadows in low-signal images. The same engineering that tames plasma turbulence will tame the raw data firehose about to hit when Atlas reappears. When the baseline of human capability rises across the board, you stop treating anomalies like oracles and start treating them like opportunities. There's another payoff to the multi-story night. Stakes. Fusion reframes climate timelines. Longevity reframes lifelines. Brain interfaces reframe dignity for people locked inside their bodies. Exoplanet spectra reframe loneliness. Each of those shifts makes the Atlas question feel less like, are we special? And more like, are we ready? Ready to sort signal from noise without burning faith or falling for fashion. Ready to accept a natural explanation without losing the joy of the hunt. Ready to accept an unnatural one without losing our minds. So here's the pact for the rest of the film. When we sprint into an update, we'll keep it short, data-rich, and connected to a question you can actually answer later. When we drift into a speculative alley, we'll pin it to a prediction the next instrument can test. When we return to Atlas, you'll feel smarter, not more confused, because the tools from the other stories will line up like lenses and bring the visitor into focus. Could this all be a coincidence? A moment when a comet, a quantum chip, a fusion plasma, a mouse brain, and a brain-computer interface just happened to break news at the same time? Maybe. Or maybe this is what the new normal looks like when curiosity compounds. Either way, widening the frame isn't a detour, it's the map. And our next stop is the one that made rare life feel less plausible by the week. 6,000 new addresses in the dark and counting. How many planets are out there? Enough that the phrase rare Earth now needs an asterisk. In 3 decades, we went from 0 confirmed exoplanets to a catalogue that just cruised past 6,000. That's not a list, that's a census. And buried in the roll call are dozens of worlds sitting in the mild, just right orbits, where liquid water could pool, cloud, rain, and run. The more we look, the more everyday planet becomes, and the stranger the specifics get. Let's get our bearings with how these worlds are found. The most prolific method is the transit trick. A planet crosses its star, the star dims by a whisper, and we measure that whisper so precisely we can tell the size of the world, how often it orbits, and, sometimes, whether its air is thick or thin. Another approach is the wobble method radial velocity, watching a star shiver in place as a planet's gravity tugs. Piece those together and you get a picture of mass and radius. From that, density. From density, a first guess at personality. Rocky, gassy, something in between. Then come the follow-ups with the bigger toys, teasing atmospheres out of the light. What's on the menu? Begin with the showstoppers. WASP 7-6b, an ultra-hot giant, has dayside temperatures that vaporize iron. That vapor rides winds to the night side, cools, and falls as metal rain. On some super-Earths hugging their stars, oceans aren't water but lava, with rock vapor hazes above like stone weather clouds. Then there's the miniature solar system of TRAPPIST-1, 7 Earth-sized worlds packed so tight their skies would be a parade of neighboring planets, some in orbits short enough to finish a year between your morning coffee and lunch. 3 sit in the so-called habitable zone. If life ever traded rocks between neighbors there, it had plenty of chances. But the headline isn't the weirdness, it's the statistics. Once you correct for what we miss, the math says Earth-sized worlds are common, and temperate orbits around cool, dim, red dwarfs are extremely common. These small stars make up the bulk of the galaxy. They live for trillions of years. If any class of world gets time to try chemistry over and over, it's theirs. Does that mean life is unavoidable? No. It means the experiment runs so often that surprise would now have to work hard. The tools are sharpening too. Space telescopes like Webb are already sniffing molecules through the faintest of signals, water, methane, carbon dioxide, and mapping cloud decks on giants we'll never visit. Roman will add a gravitational magnifying glass, catching planets that never transit at all, including cold ones at Earth-like distances. On the ground, absurdly large mirrors are rising from desert dust, with adaptive optics that cancel the twinkle of the atmosphere and aim at direct images, actual disks of nearby worlds. Not glossy magazine photos, but enough to tell light from dark, ocean from continent, weather from calm. Suddenly, Alien Weather Report is not a joke but a proposal. So where does that leave our visitor behind the sun? In context, once you accept that planets are everywhere and that planetary systems come in every flavor nature can cook, a third interstellar object drifting through our lanes doesn't feel like a magic trick. It feels like traffic. Maybe it's a frozen relic flung out by some faraway system long ago. Maybe it's something else. Either way, the highway exists. The more addresses we find, the more plausible the highways feel. Could we soon read the air of a truly Earth-like cousin and see a pattern we can't explain away oxygen and methane holding hands in a disequilibrium that screams metabolism? It's possible. Would that quiet the Atlas argument or inflame it? Both. Evidence that life pops up in many places would make a natural explanation for odd travelers more satisfying and would also teach us to keep a longer view. In a crowded galaxy with time to spare, you don't need miracles to get visitors. You just need patience and physics. 6,000 worlds is not a finish line. It's the first page of a directory we've barely cracked. Somewhere in those entries are places that will change our definitions of Earth-like, of habitable, of alone. The night sky is no longer a backdrop, it's a neighborhood. And a neighborhood has traffic, which brings us back to the object about to slide out of the sun's glare. The more we learn about the houses on the street, the less we should be surprised when something passes the window. If you want to know what a distant world is made of, you don't go there. You watch it breathe. When a planet slides in front of its star, a sliver of starlight skims through the air above that world. Molecules bite out specific colors. Split that light with a spectrograph and you get a barcode water, methane, carbon dioxide, carbon monoxide, hazes. From a few parts per million change in brightness, you can sketch clouds, humidity, even winds. This is where the game gets deliciously indirect. The planet never resolves into a disk. It's a silhouette and a subtraction problem. Yet, with instruments like the James Webb Space Telescope, we can pick out water vapor on a world dozens of light years away, see carbon dioxide on another, and infer high-altitude haze on a third. On the hottest giants, we can chart temperatures with depth and watch dayside heat get ferried to the nightside. When we stack multiple transits, weather patterns emerge as differences between passes. It's not a snapshot, it's a time-lapse in fingerprints. Could we actually see a biosignature chemistry that refuses to balance without life stirring the pot? The classic pairing is oxygen and methane coexisting in large amounts, a red flag for constant replenishment, but caution beats euphoria. Volcanoes can fake methane, photochemistry can nibble oxygen. No single line or pair of lines gets to yell life by itself. The path forward is a bundle of clues in context: gases, temperature profile, surface pressure hints, cloud behavior, stellar activity, and the planet's history. The more angles we bring, the fewer loopholes remain. What about planets that don't transit? Gravitational microlensing, Roman's specialty, will grab an army of cold, far-out worlds by watching stars brighten as foreground gravity bends their light. Those finds won't hand us spectra, but they'll redraw the census at Earth-like distances where life-friendly temperatures live. Meanwhile, the behemoths in the desert, the extremely large telescope class, will push toward direct imaging of nearby rocky cousins. You block the star with coronagraphs, tame the atmosphere with adaptive optics, and fish for a faint, steady dot. From the dot's color and polarization, you infer clouds, surfaces, and seasons. Add years of patience and you watch that dot brighten and dim as continents and oceans rotate in and out of view. It's crude cartography, but it's cartography. Here's where the temperature of the Atlas debate changes. The more we read alien weather from light, the less we lean on vibes when something looks off closer to home. Spectroscopy punishes wishful thinking. If a spectrum says CO2 dominates in one regime and organics fade as UV ramps, that's physics behaving. If a spectrum refuses to evolve when the sun should be kicking it, that's a clue to look again. The same discipline that will one day weigh oxygen against methane on an exo-Earth is the discipline we'll use to weigh carbon dioxide against water on an interstellar visitor and see whether the numbers move like thermal models. Predict. Could this all flip our story the other way? Imagine Webb, or a successor, pulls a spectrum from a nearby, Earth-sized world that stacks oxygen, methane, and a whiff of something devilishly hard to fake, maybe dimethyl sulfide or a disequilibrium pattern that laughs at abiotic chemistry. Suddenly, the galaxy feels louder. In that world, a natural explanation for strange travelers becomes emotionally easier to accept because the extraordinary is everywhere. Or the opposite happens. Life's signatures prove maddeningly rare, and odd visitors pull more weight in our imaginations. Either way, spectra are the referee, not our moods. We've reached a point where planets are not just points, they are places with weather reports encoded in light. Each report teaches us how to separate artifact from atmosphere, illusion from air. That skill doesn't stay in its lane. It follows us back to the object edging out of the sun's glare. Read the light, compare the lines, and the sky will answer in its favorite, language numbers. Let's switch from distant skies to the weirdest basement in physics, the one where numbers behave like fog. For years, quantum computing lived there as a promise with a slide deck. Not anymore. Error rates are finally edging below the practical thresholds where error correction can keep pace, and new qubit designs like cat qubits that straddle states with a built-in knack for stability are turning finicky lab tricks into systems you can actually rent by the hour on a cloud dashboard. It's not magic, it's engineering, and it's starting to bite real problems. What makes these machines special? Your laptop juggles bits that are either 0 or 1. A quantum processor juggles qubits that can be 0 and 1 at the same time, superposition, and can share fate across distance entanglement. That lets algorithms explore huge possibility spaces in parallel if you can keep the noise down. Noise is the villain. Every vibration, stray photon, or temperature twitch tries to collapse those delicate states into boring classical certainty. The breakthrough isn't just bigger qubit counts, it's cleaner operations and smarter error correction that fixes mistakes faster than the universe can introduce them. So, what can you actually do besides win buzzword bingo? Simulate stubborn molecules, for one. Chemistry is a monster for classical machines because electrons interact with everyone all at once. Quantum chips, built from the same math the electrons obey, are natural stage sets for those interactions. We've already seen practical wins where hybrid workflows feed a quantum core with a classically pruned problem and get back energy levels or reaction pathways that match bench results better and faster. That matters for catalysts, batteries, fertilizers, and yes, materials we wish were superconductors at normal temperatures. On the signals side, quantum routines can clean noisy data in ways that feel like cheating. Imagine satellite images. Marred by sunlight, glare, and sensor funk, classical filters can smear details while removing junk. Quantum-inspired algorithms can separate the two with surgical neatness, salvaging structure without erasing it. Finance desks are playing, two portfolio optimizations that used to crawl now converge faster, or at least more reliably, when quantum kernels handle the ugly combinatorics. Let's keep our hype meter calibrated. Universal, error-corrected, all-purpose quantum advantage isn't here. Today's wins are narrow and require clever hybrid designs that hand the heavy lifting back to classical silicon whenever possible. But the slope changed. Roadmaps show qubit counts and fidelities climbing together, and the cost of error correction falling. That's the part that felt like fiction a few years ago. Now it's a line on a chart with dates. Here's where our space story loops back. Better quantum hardware accelerates materials discovery. Materials discovery accelerates sensors and telescopes. Sensors and telescopes make or break our ability to say what 3I divided by Atlas actually is. If quantum-guided chemistry finds a family of high-temperature superconductors, you don't just get cheaper power lines. You get magnet systems with less cryo headache, detectors with cleaner baselines, and space instruments that can listen deeper without drowning in their own hiss. If you can measure fainter whispers, you don't argue about whether a dust cloud is leading from a single sketchy frame. You watch the grain stream in real time. There's a darker edge, cryptography. Much of today's internet security rests on math problems that classical machines find hard, but future quantum machines will find snackable. That's why standards bodies are rolling out post-quantum algorithms now, not later. Migrations of this scale move like glaciers until a breach turns them into avalanches. The responsible posture is boring. Inventory your cryptography, upgrade in phases, and avoid. Pretending that press releases equal capability, or that capability can be ignored because it's inconvenient. So where are we, emotionally, past the magic trick, into the workshop? Quantum computing has stopped asking for belief and started asking for problem sets. It remains picky, expensive, and capped by physics, but that cap is higher than it was, and climbing. The payoff for our investigation is straightforward. When reality simulators improve, our models of comets, dust, plasma, and sensor noise improve too. And that means our verdicts get sharper when the sun lets go of 3I divided by Atlas. The basement door is open. The fog is thinning. Keep your tools handy. Let's bolt an engine to an engine. Classical AI is already ravenous, chewing through data to find patterns we can't see. Quantum computing is a pattern factory in strange dimensions. Put them together, and timelines compress. That doesn't mean a sentient oracle wakes up tomorrow. It means the distance between a hard question and a credible simulation gets shorter, again and again. Here's the shape of it. Hybrid stacks are emerging where classical AI prunes a problem. Space think, molecular candidates, routing options. Portfolio states then hands the nastiest substructures to quantum routines that evaluate many possibilities at once. The feedback loops. AI learns which quantum calls pay off. Quantum routines get cleaner datasets. The result? Better guesses, faster, with fewer blind alleys. In materials science, that could mean high-entropy alloys or superconducting families discovered in silico before a single beaker clinks. In remote sensing, it could mean denoising pipelines that salvage nuance from glare and haze. In astronomy, it might be extraction of faint, periodic signatures buried in turbulent backgrounds, exactly the kind of whisper we care about when we argue over coma geometry and rotation. Money and flags have noticed. The US, EU, and China treat quantum like a strategic resource. Cloud providers are rolling out managed stacks where you can stitch AI workflows to quantum backends with a few lines of code. Startups chase photonic approaches logic with light, not frigid circuits, because photons don't mind room temperature and play nicely with fiber networks we already own. If photonics scales, you get racks of quantum-accelerated services humming beside conventional GPU farms, not in fragile clean rooms behind glass. Now the cold water. Cryptography. Much of the world's security banking, health records, the contracts that define your life, rests on problems that classical computers struggle to solve in any reasonable time. Scaled quantum machines could knock out those locks. Not today, but you don't start a fire drill after the smoke. Standards bodies are already pushing post-quantum schemes, algorithms designed to shrug at both classical and future quantum attacks. The migration will be messy, device fleets updated out of phase, legacy systems that can't change, auditors who confuse deployed with verified. But the direction is set. If you run critical infrastructure, you inventory, you test, you rotate keys, you decide in advance which systems get the new math first. There's also a subtler risk: provenance. As AI grows more persuasive and quantum pushes simulations closer to reality, the line between measurement and model blurs for non-experts. Pretty pictures and convincing curves will tempt people to skip the "did we actually observe this?" step. We fix that with discipline, publish raw data, document pipelines, and make replication boringly easy. If a brightness plateau in an interstellar visitor is real, it should survive different teams, different telescopes, and different reduction software. The more powerful our inference engines get, the more stubborn our evidence culture must become. Where does this leave our sun-hidden traveler? With better tools on its trail, AI-boosted photometry can flag microvariations in light curves that hint at stable mechanics versus messy vents. Quantum-assisted fitting can test vast spaces of jet configurations to see which patterns of non-gravitational acceleration make physical sense and which require wishful thinking. Photonic hardware, if it matures, could anchor next-gen interferometers that squeeze more resolution out of the same starlight, tightening limits on nucleus size and coma structure. There's one more geopolitical wrinkle. Breakthroughs don't arrive evenly. If a nation or consortium lands a materials win, say, magnets that hold stronger fields with less cooling, it tips the playing field in energy, computation, and sensing all at once. More sensitive detectors change what we can claim about faint things in bright neighborhoods like objects peeking out from the sundae. So the Atlas verdict will ride not just on this season's sky, but on the slope of our instrument's learning curves. Could this all be a cosmic coincidence? Or is something else going on? In a world where intelligence, human, artificial, and quantum braids together, coincidence gets crowded out by capability. We won't need louder beliefs. We'll need quieter, cleaner data. And we're building the machines to get it. Here's where the sci-fi cliché finally starts paying cash. For decades, fusion headlines sounded like postcards from Neverland. Always beautiful, never here. Then a reactor in France held a seething 50 million degree plasma for more than 22 minutes, long enough that engineers stopped calling it a stunt and started calling it a dataset. In another lab, lasers drove tiny fuel pellets past the tipping point where fusion gave back more energy than the beams put in. Meanwhile, private companies skipped the cathedral-scale machines and tried brute, clever tricks, slamming magnetized plasma rings together and promising to harvest electricity directly from the charged exhaust. Different paths, same destination, a grid that doesn't flinch. Let's demystify the alphabet soup. Magnetic confinement tokamaks and stellarators uses magnetic fields to corral plasma, the fourth state of matter, into a hot, spinning donut that wants to fly apart. Keep it hot, dense, and stable long enough, the triple product, and deuterium and tritium fuse, spitting out a helium nucleus and a fast neutron. The trick has always been the long enough. Turbulence wriggles, edge instabilities crash the party. Magnets used to be the limiting factor. Big, power-hungry, and cryogenically needy. High-temperature superconducting tape changed the calculus. Wrap those tapes into coils and you get stronger fields in smaller footprints, which means tighter plasmas and machines you can actually build without re-landscaping a country. Inertial confinement takes another road. Instead of holding plasma gently, you blitz a frozen pellet with synchronized laser pulses so ferocious that the outer layer explodes outward and the core caves inward, briefly reaching star core conditions. Cross the threshold, and you get ignition. More fusion energy out of the fuel than laser energy in. It's not plug a neighborhood today ready, but it's no longer a physics maybe, it's an engineering when. Then there's the garage band energy of private fusion. Companies like Helion and its cousins accelerate 2 rings of magnetized plasma to ridiculous speeds and let them crash. For microseconds, the pressure and temperature spike, and if the timing and fields are right, fusion happens. The bet is that you can couple that spasm directly to coils and pull out electricity without boiling water, spinning turbines, and losing half your harvest to thermodynamic paperwork. If it works, fusion plants start to look less like nuclear cathedrals and more like industrial boxes you can count and replicate. Where does the skepticism live? In the details, as always. Long pulses are great. They must become long. Seasons. Materials must shrug at neutron hammering without turning brittle or becoming radioactive headaches. Tritium, the temperamental fuel partner, needs to be bred inside the reactor blankets in a closed loop that regulators and insurers can love. Control systems must predict and choke off disruptions in milliseconds. The encouraging plot twist is that machine learning is very good at this kind of fast, pattern-based intervention. Trained on mountains of sensor data, controllers can see the prelude to a plasma crash and nudge the fields before human eyes would even name the shape. What does abundant, clean energy buy us, besides lower bills? It flips constraints. Desalination at continental scales stops being a guilty daydream. Direct air capture of carbon becomes a knob, not a prayer. Steel, cement, fertilizers, the dirty backbone of civilization, can be cooked clean. Hospitals stop rationing imaging time. Data centers stop bargaining with heat. And for our skywatching purposes, the research machine that feeds astronomy, materials, and sensors stops apologizing for appetite. Cheap, steady power means bigger magnets, colder detectors, longer exposures, and instruments that sit in perfect quiet for months. Now, connect the dots back to 3i divided by Atlas. If you can rely on abundant power, you plan bolder missions. You build next-gen interferometers that eat starlight with surgical calm. You launch arrays that watch the sun's backyard without blinking, erasing the geometry-driven blind spots that fuel rumor. You even sketch propulsion concepts, fusion-adjacent drives, beam-powered sails that shift interstellar projects from myth to roadmap. In that world, an interstellar visitor is less a miracle and more a rehearsal. Could this all still fizzle? Engineering is a jealous god. But the plot has advanced from someday to show me the next run. Fusion stayed hot long enough to matter, and once a number crosses from chalkboard to spreadsheet, it tends not to go back. The machines are learning, the magnets are stronger, the pulses are longer, and the future grid is starting to look like a canvas instead of a cage. Imagine waking up in a world where watts aren't rationed like guilt, where power is so steady and cheap that the first question isn't, can we afford it? But, what should we build? That's the mental reset abundant energy forces. It doesn't solve every problem. It deletes a constraint that quietly shaped all of them. Start with water, the civilization amplifier. Desalination today is limited by cost and carbon. Change the cost function, and coastlines become taps. Run reverse osmosis plants at continental scale, pipe inland, power vertical farms that don't care about droughts, and stabilize food supply against climate chaos. The politics get different when famine becomes a logistics problem rather than a rainfall verdict. Fresh water also unlocks ecological repair. Wetlands reflooded, aquifers nursed back, rivers given minimum flows without bankrupting cities. Energy abundance turns "we can't" into "how many?" Next, carbon. Direct air capture is notoriously energy hungry. That's why most projects today look like art installations with press releases attached. Flood them with clean power and the equation changes. Pulling CO2 from sky to stone becomes a dial you can turn, not an apology stapled to a quarterly report. Industrial chemistry follows: ammonia for fertilizers without fossil feedstocks, green hydrogen for steel, electric kilns for cement. The grim trinity of steel, cement, and chemicals responsible for a large slice of global emissions loses its excuse for smoke. Hospitals and research campuses feel the shift immediately. Imaging and accelerator time stop being rationed. Cryogenic labs keep colder baselines without flinching at bills. Data centers drop their contortions around free cooling climates and run wherever the fibers and people want them, not where glaciers and tax breaks happen to line up. Cities light their nights for safety without guilting residents. Subways run with redundancy. Heat pumps replace gas in winter without risk of grid brownouts. When energy poverty recedes, the quiet dignity of reliability spreads to places that have never had it. Fridges stop failing in heat waves. Vaccines keep cold chains. Lights stay on in maternity wards. Then look at the machines that watch the sky. Abundant power makes better magnets, cleaner vacuum, longer integrations, and arrays that can afford to stare at one patch of troublesome glare all day, every day. You build sun watchers in high orbits and at Lagrange points that erase geometry-induced blind spots, so the next mystery behind the sun never gets to hide behind phrasing. You design interferometers that stitch kilometer-scale baselines from swarms of energy-rich, cryo-stable platforms. Signal-to-noise ratios rise. Debates about, is that a real asymmetry or just processing, fade. With enough watts, patience becomes an engineering property, not a personal virtue. Transportation changes shape too. Ships and planes pull from synthetic fuels spun with captured carbon and green hydrogen. Freight rail electrifies where it hadn't. For space, abundant energy begets ambition. High-power electric propulsion, beam-driven sails, fusion-adjacent concepts that exchange propellant mass for infrastructure. You don't promise a starship next decade. You do design missions that nibble at interstellar scales, fast outer-planet couriers, Oort cloud scouts, precursors to interstellar probes that use the sun as a lens. A species that can afford long projects starts to think in long projects. There are gotchas, and pretending there aren't would be dishonest. Materials must withstand neutron battering and fusion plants. Regulatory frameworks must avoid freezing midnight science into beige bureaucracy. Transmission grids must be rebuilt to move power from where it's made to where it's needed without losing half in bottlenecks. And abundance can tempt waste, garish, careless consumption that forgets every kilowatt still carries an opportunity cost. The antidote is design, efficiency as taste, not sacrifice, transparency as norm, not audit. Now, fold this back into our running mystery. A world with energy to spare builds the instruments that make rumors short-lived. It also builds a patient temperament, because when you can keep watching, you don't need to shout. If 3i divided by Atlas is a comet, we'll know faster and more cleanly. If it's not, we'll have the power literally to follow. Abundant energy doesn't tell us what the visitor is. It buys us the time and clarity to find out. What if aging isn't a slow collapse but a setting that drifts one you can nudge back? That's the unsettling promise coming out of biology right now. A decade ago, gene editing was a miracle scalpel that could cut DNA in one spot. Today, it's a whole surgical suite-based editors that swap single letters, prime editors that rewrite phrases, RNA targeting tools that never touch the genome at all. In animals, those tools aren't just treating symptoms, they're rolling clocks. Start with the cell's identity crisis. Every cell carries the same genome, but a different layer of instructions. Its epigenome tells it which genes to use and which to shelve. With age, that control system gets noisy. Switches that should stay off flicker on, repair pathways that should be snappy go sleepy. Partial reprogramming, briefly nudging a handful of master genes called Yamanaka factors, can clean that noise without erasing identity. In mice, periodic, carefully dosed pulses restore youthful gene expression patterns and rescue function in tissues that had started to fade. Not a fountain of youth, but a mop for molecular spills. Then there are the zombie neighbors, senescent cells. They're cells that stop dividing and refuse to coll, die, leaking inflammatory signals that sour the neighborhood. Kick them out, and tissues breathe easier. Early gene therapy approaches tag these cells for removal. Others silence the signals they spew. In animals, clearing senescence has improved kidney function, muscle strength, and even hair regrowth. The lesson is loud. Age isn't a single curse, it's a stack of fixable messes. Metabolism joins the plot in a very specific way. Neurons need a steady fuel flow but can drown in sugar noise. Tweak transport or insulin-like signaling, and you watch cognition lift in elderly animals as if someone cleaned a fogged lens. Tie that to edits that fortify DNA repair, and mitochondrial housekeeping, the cell's power plant maintenance, and the effect amplifies. You're not inventing immortality, you're taking broken feedback loops and making them honest again. So, how do we keep this grounded and not drift into fantasy? Biomarkers. Aging leaves signatures, methylation clocks in DNA, inflammatory panels in blood, performance on stress tests at the tissue level. When interventions work, those dials move in the right direction, not just in mice that run mazes faster, but in the molecular reports that predict risk. That's the scientific spine we need. Edits in, biomarkers shift, function returns, and the effects persist after the spotlight leaves. What about humans? The glide path is narrow and real. First, you'll see focused therapies where the risk calculus is friendly: genetic eye diseases, single organ failures, localized degeneration. Then broader targets: osteoarthritis flares, cardiac remodeling after damage, immune rejuvenation to make vaccines punchy in older adults. Whole body age reversal remains a phrase that should make your eyebrows work out. But partial, organ-specific resets? That's a clinical trial calendar, not a sci-fi pitch. Ethics doesn't get to wait for the press release. Who gets access first? How do we test long-term safety when the promise itself is long-term? What happens to inequality if healthy decades stack on people who already have advantages? If work lives stretch, do education windows stretch with them, or do we trap people in outdated skill loops for 60 years? The technology doesn't answer those questions, it makes them urgent. And then there are the side quests that sound like plot twists but sit on honest biochemistry. Editing lipid profiles to dodge heart disease before it starts, dialing down genes that drive amyloid tangles in brains at risk, fortifying tumor surveillance so that longer lives don't become longer cancer seasons. Each of these is smaller than reverse aging, and each is bigger than the status quo. You rack up a decade of healthy life a few years at a time. Tie this back to our night's core rhythm measurement over myth. If an edit slows a clock, the clock must be one you trust when the stakes are high. If function returns, it should last long enough to matter outside a headline. The through line is simple. Aging's chaos is made of parts. Parts can be mapped. Mapped things can be fixed. And when biology stops being pure fate and starts being partly software, you begin to plan not for forever, but for better. Add 20 healthy years and society doesn't just age, it reconfigures. The calendar you grew up with, school, work, retire, starts to look like a museum piece. If health span stretches, everything chained to age metrics unravels and gets rewoven. Pensions, education, housing, caregiving, even friendship. The science is busy tuning cells, but the culture will need to tune itself just as aggressively. Let's start with the body's scoreboard. If longevity tools are real, we should prove it with clocks that matter. DNA methylation patterns trending younger after an intervention. Inflammatory profiles sliding down and staying down. Immune repertoires regaining diversity. Cardiorespiratory fitness nudging up without heroic effort. When those signals move in concert, you can plan policy around them. Retirement age becomes a function of biomarkers rather than birthdays. Insurance underwriting looks at trajectories, not candles on a cake. Risk models stop treating 65 as a cliff and start treating health as a curve you can bend. Education will refuse to stay front-loaded. If productive life runs longer, learning must become cyclical on-ramps at 35 and 55, career reskilling at 70, apprenticeships that don't assume a short runway. Universities turn into transit hubs, in, out, back in. Companies stop hoarding youth and start hoarding adaptability, because the workers who've lived through 5 tech eras are pattern recognition machines. That's not nostalgia, that's competitive advantage. Family math shifts too. Grandparents with spring in their knees are not a throwaway demographic. They're a civic power source. Multi-generational households regain economic logic. Childcare and eldercare, often pitted against each other for time and money, can dovetail when the over-70 crowd isn't defined by frailty. The loneliness epidemic, so corrosive to brains and bodies, becomes easier to fight when neighborhoods designed for mingling across ages instead of warehousing them by decade. The equity question won't politely wait its turn. Early therapies will be expensive and patchy. If health span lengthens first, for the already fortunate, inequality hardens, not softens. That isn't a fate, it's a policy choice. Public trials can demand open data and cost transparency. Regulators can tie approvals to access plans. Philanthropy can do what it's best at, de-risking early-stage interventions in communities that markets ignore. The alternative is a caste system measured in years rather than gold. Work itself becomes less of a sprint and more of a marathon with scenery changes. Instead of a single 25-year climb and a sudden stop, imagine a sequence of arcs: build, sabbatical, pivot, mentorship, repeat. Burnout loses its inevitability when rest and retraining are baked in. Creativity, which loves cross-pollination, benefits when a 62-year-old climate modeler spends a year in urban planning and brings the math with her. There are guardrails to install before the road opens. Safety signals must outrun hype. No one needs a rejuvenation therapy that trades arthritis for cancer 5 years later. Informed consent must actually be informed, with risks communicated in adult language, and measurement culture must reject self-anointed biohackers as proxies for medicine. N equals 1 is motivational. It isn't evidence. The gold standard remains boring and beautiful. Randomized, controlled, peer-reviewed, replicated. Zoom out, and you see how this feeds back into our cosmic storyline. A species that expects longer, healthier lives thinks in longer, healthier projects. Budgets stretch across decades because citizens do. Patience becomes affordable. You can commit to a 30-year climate plan and a 30-year telescope in the same breath. You can staff missions that watch the sun's backyard without blinking for a generation. If 3I divided by Atlas is part of a larger pattern of rare visitors, we finally have the civic metabolism to notice the pattern without screaming or sleeping through it. The most human question remains close to the ground. What do we do with extra time? More of the same is the wrong answer. The right answer is more of the meaningful relationships tended, skills layered, communities stitched tighter. The technology buys the years. We decide what those years are for. If we get that decision right, longevity won't just be longer life. It will be a broader one, with room for curiosity that doesn't panic and wonder that doesn't fade. Here's a sentence that would have sounded like fantasy a decade ago. A paralyzed man just typed nearly as fast as you can text, using nothing but intention. No hand, no voice. His thoughts walked across a screen because a film thinner than a hair listened to thousands of neurons at once and translated their chatter into letters. Another patient guided a robotic arm to lift a cup and drink routine for you, a revolution for her. This is not futuristic charity, it's engineering meeting dignity. Let's peel the layers. Traditional brain implants drilled deep and asked a handful of neurons to shout. The new wave lays a flexible sheet on the cortex, where signals are strong but surgery is gentler. That sheet listens broadly, captures patterns, and feeds them into decoders trained on the user's own neural signatures. Think autocomplete, but for movement and language. The model learns your brain's accent. You learn the system's patience. Somewhere in the middle, communication blooms. The procedure can be quick. Reversibility is no longer a fantasy. That flips the risk-reward math for people who've waited too long for someday. Not every interface needs a scalpel. Non-invasive systems are getting clever using optical sensors, magnetometers, or EEG arrays with better algorithms to pull intent from noisy measurements. They're slower and fuzzier than cortical films, but they don't ask you to sign surgical consent. For everyday control typing short messages, navigating a phone, selecting words they're crossing from lab to living room. The gains are lopsided but real. A silent yes, where there used to be nothing at all. Now, the piece that makes neuroscientists sit forward. These interfaces aren't just output devices, they're mirrors. As we map intention to action, we're catching glimpses of how consciousness organizes itself. One compelling model casts the brain as a prediction machine, obsessed with the body heartbeats, breathing, gut signals. It forecasts the next internal moment and corrects when reality disagrees. Consciousness may emerge from those correction moments, the mismatch between expectation and sensory truth. If that's right, then plugging a human into a feedback loop where thoughts make pixels dance offers a new microscope. You can perturb the loop and watch experience bend. The ethics arrive on schedule. If you can read intent, you can also infer more than the user meant to share: mood, stress, fatigue. If you can stimulate to help nudging a motor cortex or a mood circuit, you can also misfire or be misused. Consent cannot be a signature, buried on page 9. It must be a living, revocable contract grounded in interfaces that display what they collect and let users shut the door. Privacy isn't an add-on, it's part of the circuitry. There's a frontier beyond medicine. Thought-to-text is a convenience for the able-bodied too. Hands busy, thoughts connected, games controlled by intention alone. Workflows where a glance and a verb carry you through an app. None of this requires science fiction levels of precision. It requires systems that respect error, adapt quickly, and fail safely. It also requires a cultural throttle. We do not need omnipresent mind pointers. We need tools that expand agency without collapsing boundaries. How does this fold back into our larger investigation? Interfaces will sharpen our sense of what counts as evidence when we talk about minds, ours, or anyone else's. If consciousness depends on body-brain prediction loops, then building machine minds that feel like ours may require machine bodies or simulated guts. That makes alien intelligence a heavier phrase. It teaches humility. Before we can judge strangeness in the sky, we ought to understand the stranger under our skulls. Here's the sober promise. Brain-computer interfaces are moving from miracle case studies to reliable instruments. They give speech back. They give movement back. They also give us a language to talk about awareness, with fewer metaphors and more measurements. When thought hits the screen, the line between idea and action gets shorter. Use that line well, and the next chapters about manipulation, memory, and free will become less spooky and more solvable. What happens to consciousness when you dim it, distort it, or pull it apart and put it back together? Anesthesia offers the cleanest lever. Drift under carefully, and the lights go out. But monitor the brain with high-resolution tools, and it doesn't look like a switch. Awareness flickers, reorganizes, and sometimes sparks in unfamiliar corners. Patients report vivid scenes from stretchers where traditional monitors said, "Nobody home." That gap between report and readout is not a ghost story. It's an instrumentation challenge. It says our yardsticks for awareness are still coarse, and that conscious experience may survive in forms our meters shrug at. Then there's the opposite lever, psychedelics. Give the brain a compound that loosens habitual patterns, and the networks that enforce your I relax their grip. The default mode network, your narrative autopilot, quietly steps back. Connectivity blooms. Subjects describe clarity without an ego, perception without the incessant commentary of self. Recordings show activity becoming more diverse and less predictable, like music that keeps composing itself in new keys. Whether or not you care about mystical language, the data hint at a mechanical truth. The mind you feel is a negotiation among modules, and changing the balance changes the feeling of being you. Now stitch minds together, however clumsily. Brain-to-brain experiments remain primitive cooperative games where one person sees the target, another sees the controls, and both must synchronize intention to succeed. The accuracy is far from telepathy, but the principle is undeniable. Signals harvested from one skull can shape behavior in another. For the military, that's a dream of silent command and swarm control. For ethicists, it's a nightmare if done without consent. In between lies civilian use, collaboration tools where hints and hunches flow faster than words, creative pairs composing in sync like tightly coupled jazz brains. Corporations smell convenience. Non-invasive headbands promise thought shortcuts for typing, cursor control, and AR interfaces. Phones and glasses could read micro-intentions the way keyboards read thumbs. The pitch is speed. The risk is spillover. Systems that guess your intent can also learn your tells boredom, stress, arousal, and keep those in their training buffers. Unless we demand boundaries, the same telemetry that helps you select a word could help an app select a nudge that keeps you scrolling. The fix is transparent design, explicit displays of what's collected, local processing by default, encryption on anything that leaves the device, and hard-off switches the user can trust. Stimulation flips the loop. Instead of reading intent, you write into Cortex. Medical use is already saving lives, interrupting seizures, breaking depressive loops, restoring motion maps after stroke. But precision is a double-edged word. Nudge the wrong rhythm, and cognition blurs, hit the right one, and performance spikes. Even modest transcranial techniques can shift reaction times, memory, or mood. That makes enhancement a retail category waiting for regulation. A culture that already optimizes sleep, diet, and steps won't ignore knobs on attention and creativity. Guardrails must arrive before every exam and tournament turns into an arms race of quiet zaps. So what is consciousness under the microscope? Not a single flame behind your eyes. More like a campfire made of many small fires: breath, heartbeat, gut, sight, touch, posture, each sending predictions upstream, each corrected by reality, with awareness arising in the differences. That model explains anesthesia's flicker, psychedelic dissolves, and why interfaces that close the loop between intention and effect feel so empowering. Fewer steps between prediction and correction. Here's the caution that circles back to our larger mystery. If we can push and pull awareness with chemistry and electricity, the line between perception and persuasion thins. Environments already use color, sound, and timing to steer our choices below awareness. Add neural read-write, and you have a world that can, in principle, tune states of mind the way it tunes playlists. The defense is literacy and consent. Know the levers exist. Demand the right to see and seize them. And remember that skepticism isn't cynicism, it's a seatbelt for curiosity. Before we judge strangeness in the sky, or pronounce a visitor natural or not, we should get comfortable judging strangeness within. Consciousness is not sacred because it's fragile. It's sacred because it's adjustable. When you learn to adjust it wisely, you stop fearing the dark room of your own mind and start using it as a lab. That's where the next section leads. The memories we trust, the ways they bend, and how to keep them from breaking. Your memories feel like photographs in an album. They aren't. They're stories your brain rewrites each time you open the book. That's not poetry, that's lab work. Put someone in an experiment, show them an event, then have a trusted voice retell it with a small twist. Scan the brain and watch the hippocampus, the index of experience, light up like it's forming a brand new memory. The person doesn't doubt what they saw. Their brain updates the file. Gaslighting works not because people are weak, but because our recall system is built to prioritize group truth over solitary certainty. For most of our species' history, belonging beat being right. The mechanism is devastatingly practical. Memory is reconstruction, not replay. When a new narrative arrives from a source you've learned to weight heavily: family, authority, a feed you check 100 times a day, prediction circuits, treat it as the better map and refit the terrain. Next time you remember, you're actually remembering the last remember. It's efficient. It's also why confidence and accuracy often travel separately. Tilt the system from the other side, and you see how physical it is. In animals, optogenetics lets researchers label the neurons that fired when a memory formed, and later tickle them with light. You can make a mouse freeze in fear in a perfectly safe box by replaying the cells etched during a shock somewhere else. You can also do the reverse. Quiet a fearful trace and watch behavior soften. The lesson transfers, even if the tool doesn't. Memory is addressable. It has wiring. It can be flipped. Diet reaches into the circuitry too. Flood the brain's fuel system with fast sugar and inflammatory signals for a few days, and the hippocampus goes noisy. New memories slip, old ones wobble. Dial the metabolic chaos down, and the signal cleans up. This isn't moralizing, it's maintenance. The brain is an energy accountant. When the books are a mess, the index gets sloppy. So where's the hope? In the same plasticity that makes us vulnerable. When scientists stimulate the correct pathway in mouse models of Alzheimer's, lost memories reappear. It's not that the file was deleted, the pointer failed. Human trials with focused ultrasound are probing similar ideas, trying to jiggle locked doors without cracking the hinges. Early results hint that at least some forgetting is an access problem, not a bonfire. That rebrands dementia partly from erasure to misrouting. Mourn less, rewire more. What can you do without a lab? Treat memory like a craft, not a gift. Externalize the things you care about. Journals, spaced reminders, photos paired with written context while details are fresh. Sleep like it's sacred. Consolidation isn't optional downtime. It's the nightly print run. Eat in ways your future brain will thank you for fewer spikes, more steadiness. Learn to spot the social tells of memory editing, confident retellings that shrink dissent, repeated phrasing that overwrites nuance, emotional hooks attached to alleged facts. When something important is at stake, triangulate with other minds you trust and with records you control. Literacy here is armor. There's an ethical dimension we can't dodge. If you can bend memory in a lab, someone will try to bend it in the wild platforms tuning timelines for engagement, campaigns massaging narratives, bad actors laundering falsehood through friends. The defense isn't paranoia, it's procedure. Ask what would disconfirm a claim before it calcifies. Archive first impressions if you'll need them later. Slow down the share reflex when a story flatters your tribe. Your hippocampus is talented. Don't make it a stenographer for someone else's agenda. Bring this back to our larger investigation, and the object easing out of the Sunday. The same brain that stitches images into a narrative is the brain judging whether a fuzzy asymmetry means anything at all. Know your update rules and you resist being played by rumors, by your own biases, by the seductive neatness of a plot. Memory is hackable, which means it's maintainable. Guard it, train it, and it will serve you when the evidence starts to talk louder than the stories. How free is a choice that shows up on a graph before you feel it? In labs, electrodes and scanners can predict which hand you'll lift several seconds before you report deciding. It's not mind reading, it's pattern reading. Neural assemblies ramp toward an action, the ramp crosses a threshold, and only then does your conscious narrator claim authorship. That doesn't mean you're a passenger. It means the conscious I may be more editor than author, setting goals, vetoing impulses, training the habits that generate those ramps in the first place. Zoom out to a different, slower variable: loneliness. Chronic isolation doesn't just hurt feelings, it rewires tissue. White matter pathways change. The default mode network, the brain's daydream engine, goes into overdrive, while regions tuned for vigilance and threat stay primed. In that state, the world feels sharper at the edges and duller in the middle. You scan for danger, ruminate more, and your memory system preferentially stores the slights. If a society wants citizens who can weigh evidence calmly, it can't afford to let millions live in cognitive siege. Now add the environment as puppet master. Retailers already tune music tempo to alter walking speed. App designers choreograph color, timing, and micro rewards to shape your scroll. Experiments show that flashes of certain hues for fractions of a second too quick to notice shift mood and choice for hours. Temperature nudges generosity. Humidity dulls patience. The modern world is a behavioral lab with better A divided by B testing than any university department. None of this requires brain implants. It requires curiosity about response rates and a willingness to treat people like levers. Where does agency live in this mess? In the boring superpower called metacognition, watching the mind while it does mind things. You can't stop a readiness potential from building toward a choice. You can alter the training set that makes that choice likely, the context that invites it, and the veto that cancels it. Think of freedom not as a bolt of lightning, but as a thermostat. You don't conjure a room's temperature from nothing. You set the parameters and let the physics work. Habits, sleep, diet, and social contact are knobs on that thermostat. Meditation isn't mysticism here. It's a gym for control circuits. Regular practice thickens and strengthens networks involved in attention and self-regulation. In experiments, people who train this way show less susceptibility to subtle manipulations and quicker recovery from emotional jolts. Exercise does similar magic. From the body side up movement recalibrates the chemical weather that your predictive brain reads to infer mood. Add structured breathing, and you get a portable lever for downshifting arousal when an environment tries to jack it up. What about hard protections in a world optimized to harvest attention? Design your life like you design a lab. Put friction where you want less of something. Grayscale your phone, bury the noisiest apps in folders, Schedule Do Not Disturb as default and Permission as exception. Put grease where you want more. A book on the pillow, running shoes at the door, a calendar block called Friends that repeats without apology. External constraints aren't admissions of weakness. They're scaffolds for choosing well when your future self is tired. The justice system will have to wrestle honestly with the neuroscience. If choices gestate before awareness, culpability gets complicated, but not erased. The law already distinguishes between impulse and intent, capacity and coercion. Stronger brain evidence sharpens those lines. It doesn't dissolve them. The humane response is not to shrug no free will. It's to invest in environments, treatments, and education that tilt ramps toward pro-social choices and build veto power where it's thin. Bring the thread back to our skyward riddle. A mind steered by loneliness, fatigue, and design tricks is a mind that will overread a noisy image or underweight a dull dataset. A mind with trained attention, social ballast, and decent sleep is better at holding the question open until numbers decide. Freedom, in practice, looks like the capacity to wait for evidence while the world, digital and biological, tries to stampede you. That's the kind of freedom we need in the next act, where we return to our interstellar visitor and set the final scorecard. Time to cash the checks we wrote in Act 1. The sun is giving 3i divided by Atlas back, and the only way this stays a mystery is if we choose vibes over measurements. So here's the scorecard we'll use together: simple, public, testable. First, brightness behavior. Natural comets obey a family of power laws tied to distance from the sunday. Post-perihelion, the curve should fall fast at first, then smoothly over nights and weeks. Short-term wiggles are fine, vents cough. What we're watching for are step changes that don't line up with heating. Plateaus when cooling should darken it, surges when nothing thermal changed. If the light curve glides down on schedule, we chalk a point in the magnificently natural column. If it breaks into terraces and stalls, that's a bookmark. Second, spectra that breathe. Split the light and track the lines: water, carbon dioxide, carbon monoxide, organics. As geometry and sunlight change, those fingerprints should wax and wane in ways models predict. Lines that refuse to move are suspicious. Lines that pop in or out on human convenience aligned with calendars, not heliocentric distance, are more suspicious. Expect evolution, doubt constancy. Third, the push. Precise positions against background stars, night after night, reveal non-gravitational acceleration. Heat-driven jets push mostly sunward with a little seasonal bias from rotation. We'll reconstruct a tiny vector that should point where the sun points the hose. If that vector wanders off script and stays stubbornly cross-sun without event story to explain it, the eyebrows go up. We're not expecting cinematic turns, just millimeter-per-second confessions that add up over time. Fourth, rotation. Early hints of a tidy period about 17 hours set the trap. Real comets near the sun often change spin as vents open, clog, and move torque around. Periods drift. If the beat wobbles with heating, that's comfort. If it stays metronomic across changing activity, we take notes. Bonus watch item: a secondary modulation nested within the main period that can't be blamed on shape alone. If it appears and stays stable in frequency, that's interesting. Fifth, coma geometry. The asymmetries we saw at low signal should either clean up or recur across independent instruments. A forward nose that survives different telescopes, different processing pipelines, and different phase angles deserves attention. If it melts away under better seeing and saner reductions, we file it under optics are tricksters. Sixth, the window antics. Late November to early December is the rumoured do things unseen gap. If there's any transient along the earthward line, a faint, consistent source, trailing or preceding stacked wide-field surveys will be where it hides. If nothing shows, the rumour is just that. If something does, we won't need all caps tweets. We'll need follow-up nights. Here's how you can actually follow this, not as a spectator, but as a participant. Amateur networks will publish photometry nightly. We'll compare raw magnitudes and normalized curves. Observatory logs will post astrometry that anyone can fit with public tools. We'll see the non-gravitational term settle or squirm. Spectra will arrive in preprints and archives. Even a simple line strength ratio plotted against distance tells a story. We won't move the goalposts. We wrote them down. So what are the plausible endings? Ending. A. The light curve fades on cue, lines evolve with heat, the push points sunward, the rotation wanders a bit, and the coma's quirks turn into ordinary anisotropy with better data. We breathe out and call it what it likely is, a natural, gloriously odd interstellar comet wherein chemistry we don't see at home. Ending B. One or more pillars refuse to behave, brightness stalls, vectors misalign, rotation locks too cleanly, a foreglow persists. We won't jump to artifact, but we will upgrade the question and design new tests. Either way, we win something valuable, proof that suspense can be resolved by patience, that public data can outpace rumor, and that curiosity doesn't have to choose between romance and rigor. When the plots and points settle, we'll call it straight. If nature wrote this script, we'll applaud. If someone else did, we'll adjust our maps and keep looking up. Stand outside tonight and pick a star. Behind its steady pinprick is a clockwork of worlds, weather, chemistry, and time. Behind your own eyes is a clockwork just as intricate: electrical storms, chemical tides, and a memory system that edits as it saves. The real story we told tonight isn't about one object hiding behind the Sunday. It's about clocks learning to read other clocks, about instruments that turn whispers into numbers, and about a species getting better at telling when it's fooling itself. We chased a visitor because its timing was rude and its geometry convenient for troublemaking. We sketched the tests that would embarrass us if we were wrong and hold up if we were right. A light curve that fades like heated ice, spectra that breathe with the sun, a non-gravitational nudge that bows toward heat, a rotation that drifts when vents change their minds, a coma that stops looking like a forward nose once the optics get cleaner. The payoff isn't the verdict, it's the discipline of writing the verdict's rules before the verdict arrives. Along the way, we widened the frame. 6,000 planets reminded us that rare is a feeling, not a fact. Spectroscopy turned silhouettes into meteorology. Quantum hardware moved from slogan to simulator. Fusion plasmas held their shape long enough to be boring, which is exactly how you want your revolutions. Gene editors and reprogramming factors moved aging from myth to mechanism. Neural interfaces gave words back to bodies and handed us a clearer mirror for consciousness. Psychology walked us through memory's malleability and taught us the difference between being persuaded and being programmed. None of those detours were detours. They were the scaffolding that keeps a story, like Atlas from collapsing into hashtags. So where does that leave us when the next rumor pokes its head over the horizon? Wiser, if we choose to be. Curiosity should be caffeinated. Claims should be carb-free. We can say, this is thrilling, and this needs proof, in the same breath. We can hold contradictory possibilities in tension without laundering them into mush. We can use our tools, telescopes, labs, and yes, habits to turn what if into here's what the data did. That isn't self-denial, it's self-respect. There's also a quieter pledge embedded in the science to use new power without becoming its puppet. Abundant energy without waste, longer lives without longer inequity, brain-machine links without surveillance creep, algorithms that help rather than herd. The same stance that keeps us from falling for a doctored comet image keeps us from sleepwalking into a doctored life. Literacy is liberation, and yet leave room for awe. The universe does not owe us clarity. It offers secrets at the pace we earn them. Some nights the numbers line up and a mystery dissolves into the satisfaction of a solved puzzle. Other nights the numbers tease and we step back, sharpen our tools, and return with better questions. Both are wins. Both build a culture where wonder and skepticism are partners, not rivals. If 3I divided by Atlas is just a beautiful comet from a strange nursery, that's not a demotion. It's an origin story written in ice and sunlight, stretched across light years, arriving in our century because physics said so. If it's more than that, then we get to start a different kind of chapter, one where the map of natural grows a new peninsula labeled made, and where we learn to talk about it without setting ourselves on fire. Either way, the sky above and the mind within are teaching the same lesson. Reality is richer than our first drafts, and truth rewards patience. So keep your eyes up and your methods tight. Ask the spiciest questions you can, then let the instruments answer. Share what you learn without juicing the story. Be wary of certainty that arrives faster than data. Celebrate the ordinary, because tonight's ordinary 6,000 planets, 22-minute plasmas, a man's thoughts typing hello would have been sorcery to your grandparents. We are, as someone wiser said, a way for the universe to know itself. That knowing doesn't come as thunderbolts. It comes as curves on a plot, as spectra with lines slightly stronger this week than last, as a hand that can lift a cup again. It comes as a comet that was more patient than we were. And it comes as a community curious, stubborn, alive, willing to look, to measure, to wait, and to learn.